Welcome to How to Master Error Handling in Claude API with Python. Today, we'll learn to handle errors, implement retries, and ensure seamless API interactions with Claude using Python.
Did you know that over 60% of API failures are due to improper error handling? Welcome to today's session where we dive deep into mastering error handling when working with the Claude API using Python. Whether you're a seasoned developer or just starting, understanding how to handle errors efficiently is critical to building robust and reliable applications. In this video, we'll explore common errors you might encounter with Claude API, implementing basic error handling strategies, and setting up retry logic for transient errors. We'll also cover using exponential backoff, logging errors for monitoring, handling rate limits, and testing error scenarios in Python. Let's get started on this exciting journey to master error handling in Claude API. When dealing with the Claude API, or any API for that matter, it's crucial to understand the common errors you might face. These can range from client-side errors, such as incorrect request formats, to server-side issues, like downtime or overload. Network-related errors could also occur, impacting your application's ability to communicate with the API. Authorization errors are another category, often stemming from incorrect credentials or permissions. Additionally, data format errors can arise if the data sent or received does not adhere to the expected format. Recognizing these common errors is the first step in implementing effective error handling strategies. It sets the foundation for developing robust applications that can gracefully manage errors and maintain seamless API interactions.
Python offers powerful built-in error handling capabilities, which are essential when working with APIs. The try except block is a fundamental tool for capturing and responding to exceptions. By wrapping your API calls within a try block, you can catch specific exceptions using the except clause and handle them gracefully. This might involve logging the error, retrying the call, or alerting the user. Additionally, the finally clause ensures that certain cleanup operations are always performed, regardless of whether an error occurred. Let's look at a simple example. When making a request to the Claude API, wrap your call in a try block, catch exceptions like connection error or timeout, and handle them accordingly. This basic error handling strategy will significantly enhance the resilience of your application, allowing it to respond effectively to unexpected issues.
To leverage try except blocks effectively, it's important to catch multiple exceptions that might arise during your API calls. This allows you to provide specific responses to different error types, enhancing your application's robustness. Additionally, Python's try except block supports an else clause, which runs when no exception occurs, allowing you to separate successful execution logic from error handling. Avoid using bare except statements, as they catch all exceptions, including programmer errors that should typically halt execution. Instead, specify the exceptions you expect, such as pair or JSON decode error, to ensure precise exception handling. Logging errors within your except block provides valuable insights into the issues your application encounters, facilitating debugging and monitoring. By prioritizing exception specificity and incorporating logging, you can build a more resilient error handling strategy for your API interactions. Transient errors, such as temporary network failures or service unavailability, can often be resolved by retrying the operation. Implementing retry logic is crucial to ensure that your application can recover from these temporary issues without user intervention. Start by identifying transient errors you might encounter with the Claude API, such as 503 service unavailable or network timeouts. Use Python libraries like retrying or tenacity to implement retry strategies effectively. Control the number of retry attempts to avoid overwhelming the service and incorporate delays between retries to give the system time to recover. This can be done using fixed intervals or more sophisticated approaches like exponential backoff, which we'll discuss in the next section. By setting up intelligent retry logic, you can significantly improve your application's resilience against transient errors and enhance the user experience.
Exponential backoff is a strategy for managing retries that gradually increases the delay between attempts, reducing the load on the server and improving success rates. The idea is simple: start with a small delay and double it with each consecutive retry. This approach prevents aggressive retry patterns that could exacerbate server issues or lead to rate limiting. Implementing exponential backoff requires balancing the number of retry attempts with the delay durations to optimize recovery without overloading the server. Python libraries like Tenacity offer built-in support for exponential backoff, making it easy to incorporate this strategy into your API interactions. By using exponential backoff, you can manage retries intelligently, ensuring that your application remains responsive and robust even in the face of transient errors.
Effective error logging is a cornerstone of robust error handling and plays a vital role in monitoring and debugging your application. By capturing detailed log messages, you gain valuable insights into the issues your application encounters, making it easier to identify and resolve problems. Start by choosing appropriate logging levels, such as debug, info, warning, error, and critical, to categorize the severity of each log message. Python's built-in logging module provides a flexible framework for implementing logging in your application. Structure your log messages effectively by including relevant information such as timestamps, error types, and context. This ensures that your logs are informative and actionable. Regularly monitor your logs to identify patterns, diagnose issues, and optimize your application's error handling strategy. By prioritizing effective error logging, you can enhance your application's reliability and maintain a high level of performance.
API rate limits are designed to prevent abuse and ensure fair usage of resources. However, exceeding these limits can lead to errors and degraded performance. Understanding the rate limits imposed by the Claude API is crucial for maintaining a seamless integration. Implement rate-limiting strategies to prevent your application from exceeding these thresholds, such as batching requests or spreading them over time. Avoid making unnecessary requests and optimize the frequency of your API calls to stay within the allowed limits. Utilize Python libraries or custom logic to monitor your API usage metrics, ensuring that your application adheres to the established rate limits. By managing rate limits effectively, you can maintain optimal API performance and enhance the reliability of your application. Testing your error handling logic is essential to ensure that your application can respond effectively to various error scenarios. Begin by simulating common error conditions that your application might encounter, such as network failures, timeouts, or server errors. Use testing frameworks like PyTest or Unitas to automate your tests and validate your error handling logic. By systematically testing different error scenarios, you can identify weaknesses in your error handling strategy and improve your application's robustness. Document your test cases and results to track your progress and facilitate future testing efforts. Regular testing not only enhances the reliability of your application but also provides confidence that your error handling strategies are effective and comprehensive.
We've covered a lot today about mastering error handling in the Claude API using Python. From understanding common errors to implementing retry logic and using exponential backoff, these strategies are essential for building robust applications. Remember, effective error handling not only improves reliability but also enhances the user experience. If you found this video helpful, please give it a thumbs up and share it with others who might benefit. We'd love to hear your thoughts and questions in the comments below. Don't forget to subscribe for more content like this, and let us know what topics you'd like us to cover next. Thank you for watching, and until next time, happy coding.